All right, so today we're going to be talking about proportional relationships, and we're going to use equations to show proportional relationships, and then we're also going to use graphs to show proportional relationships, and then you guys will do a little bit of practice with that. So I'm going to give you again a very small homework assignment as we work on this idea, and then give you the rest of the period to look over your test. And I would highly recommend that you actually take that seriously and do your best with it. So let's talk about some things. We're going to do a little bit of an explore activity first. So our objective is to understand what is a proportional relationship, and then we're going to use tables and graphs to represent proportional relationships. So we're going to do, I'm going to give you the standard number, because if you go on to Virtual Nerd, you can look up this standard and get help on it. So 8EE6. And what this is going to lead into is looking at the idea of rate of change, which talks about slope, which ends up helping us graph lines, and so on and so forth. So this is kind of just a basic idea. The other thing I wanted to give you were some personal math trainers. And remember, the personal math trainers kind of take you through the ideas, so when you get onto the homework, it helps you already do the homework. So there's a personal math trainer on page 74. So when you log in, you can find the personal math trainer from page 74. There's also one on page 75. And so the first one is going to be dealing with using tables to represent the proportional relationships. The second one is going to be talking about the graphs. So this one is the tables, using tables, and this one is using graphs. Okay? So let's talk about the definition, and then we'll do kind of a explore activity. So let's talk about what is the definition of a proportional relationship. So if we have a relationship that's proportional, that means it's a relationship between two quantities It's not a very good two. So that the ratio, so that's a fancy way of saying fraction, of one quantity to another quantity is constant. So it's the idea of constant that's really important for proportional relationship. So, for example, when you are looking at a map in class, they give you a ratio of what size the map is to how that corresponds to the real world. So that's not going to change on that map. So it's not 1 inch is 30 miles in this part of the map and 1 inch is 50 miles in another part. It's got to be 1 inch represents 30 miles throughout the entire map. And so that relationship, 1 inch to 30 miles, is constant. So that's a proportional relationship. Okay. Okay. So how many of you have you ever read the book 20,000 Leagues Under the Sea? You read that book, Jules Verne? He's kind of a science fiction writer, and it's about this alter world that's underneath the ocean. It's actually quite interesting. I've never been a fan of science fiction or fantasy like that, so that one actually was, I enjoyed reading that one. So basically, the word league is a measurement that you use in water. So we need to know this one piece of information as we go through this. So 1 league is the same thing as 3 miles. So just like we would have, a map with its scale factor of what you see on the map compared to what is reality, it's the same idea. So 20,000 leagues under the sea. So that's a lot of miles. So what we're going to do is create a table using this idea. So we're going to have the distance in leagues. Oops. And we're going to compare it to the distance in miles. I'm having trouble drawing today. So if, oops, wrong spot. If I have 1 league, according to my definition, how many miles does that give me? Say again? It would give me 3, right? Okay. If I had 2 miles, how many leagues would that give me? Okay, 6. If I had 6 leagues, how many miles would that be?
18.
Okay, oh, now I'm hearing more voices. Starting to get a pattern here. If I had, ooh, I'm going to trip you up a little bit. What if I had 36 miles? How many leagues would I have?
12.
Yeah, I have to go the other direction with that conversion factor, so I would have 12. And so here comes the grand number. If I had 20,000 leagues, how many miles would I have? 60,000 leagues. Okay. So basically, what do you see is the relationship between all the numbers in the chart. And there might be different relationships that you see in the numbers. So what's something that you notice? Joy?
The top number times 3 equals the bottom.
Okay. So top number I'm going to say league, just to keep us straight, what I mean by the top number. Top number times 3 equals the bottom number, which is our miles. Okay, good. So when we want to figure out the ratio, because remember that proportional relationship is 2 quantities in which the ratio of one quantity to the other is constant. You working on a test?
No, I got in trouble.
Okay. So let's work on some ratios here. So let's take and let's put it in miles over leagues. Okay, so for all of these we want to do miles over leagues. So let's take the first column. And we have 3 over 1. Okay? And I'm going to leave it because its ratio has to have 2 numbers that I'm comparing, so I'm not going to take the 1 away. All right, so I'm going to leave it as 3 to 1. Okay, so let's look at the second column. Miles over leagues. Can I simplify that?
Yeah.
And what does that become? 3 over 1. Okay. All right, let's take the next one. I have 18 to 6. And what happens when I simplify that one?
6 over 3.
6 over 3.
There, 11, 3.
6 over 3. It wouldn't be 6 over 3.
It's like
3 over 1.
Yeah, it'd be 6 over 2, which would then give us 3 over 1. Okay. And then,
3 over 1.
oh, yes, somebody figured it out. And 36 to 12, 3 over 1. And 60,000 to 20,000,
3 over 1.
3 over 1. So what we should notice is all the ratios of miles and leagues was exactly the same, okay? So all the ratios equal 3 over 1, according to the way that we listed miles over leagues. Now, if I said, how about leagues to miles, what would you have written?
1/3.
1/3, and they would be all the same, okay? All right? So let's add one more thing. If you know the number of leagues, what would you do to change it into miles? Now, let me change colors here. So, number of leagues what would you do to it to equal the number of miles?
Divide by 3.
So the number of leagues, which is the top number, if I divided it by 3, do I get 6? So 2 divided by 3 is 2/3. So that won't work.
Didn't we already write it down?
Oh, you multiply.
Oh, what do you multiply by?
3.
Okay. So if I know the number of leagues, and I multiply by 3, well, this is an observation, yeah, so we should be able to get that one right. Then we're going to get the number of miles. Okay, so let's turn this around. What if we have the number of miles,
Divide by 3.
and we want to figure out the number of leagues? Say it again, Jonah.
Divide by 3.
Yeah, we're going to divide by 3. Okay? All right, so in this particular problem, we took, anytime we had any number of leagues, we could multiply it by 3 to get to the number of miles. And on that one weird one where they had given us the miles, we could divide by 3 to get to the number of leagues. So that 3 has a name, okay? And so we want to talk about that. Oh, sorry. Okay, so the other term that I want to introduce you to is what's called the constant of proportionality. As you may hear this. That's a long word. Proportionality. And in our particular one, the one we just did, the constant was the number of leagues to the number of miles. So 1/3 was actually the constant of proportionality. So to go from one to the other, I always use that same value. I didn't change that value that I was using. Okay, the only change I did was what math would I do depending on what label I started with. Okay, so the constant of proportionality looks like you have an equation that looks like this. And so this value is what I'm doing to the one value to get to the other value. So they call that the k value, and the k value is the constant of proportionality. Okay? So for us, if you divide both sides by k, or by x, I'm sorry, to get the k alone, you would get y over x. So for this one, the leagues would be represented by the y, and the miles would be represented by the x, and that's the same as the 1/3. Okay, so we're going to do an example problem, and we're going to see if we can come up with a table that would help us, and then see if we could write an equation that we could use that would help us. So All right. So 15 bicycles are produced each hour at a particular bike company. And we need to show the relationship between the number of bikes produced and the number of hours is a proportional relationship. And then we're going to write an equation for that. So let's write down some pieces of information. We have 15 bicycles produced per hour. Okay? 15 bicycles produced per hour. So every hour, 15 bicycles are created. Right? If I wanted to write this as an equation, so the number of bicycles produced is based on, in total, would be based on how much time I'm producing them, right? So let's let y equal the total number of bicycles produced and by the way, another way to write this is using the labels bicycles per hour. So what's my x going to equal if I write an equation here? What else do I need to know in order to figure out the total number of bicycles produced? If I can get 15 done in an hour. Joy?
How long, or how long it takes.
Okay, so we're going to use the terms that are given here. Instead of just saying how long, how many hours? So how many hours does production last? Okay. So if I want to get a total number of bicycles produced, knowing there's 15 bicycles produced per hour, and there's been X hours that I'm producing them, how would I write an equation to represent those things? What math am I going to use? Okay. What am I going to be multiplying, Connor?
X and Y.
I cannot multiply the total number of bicycles by how many hours I've done that and come up with the total number of bicycles. That won't work.
Oh, 15 bicycles I don't know.
Okay. Remember what my goal is. Which one of those three things should be all by itself? The 15, the Y, which represents total number of bicycles produced, or the X, total number of hours production lasts. Which one of those should be by itself? We want to figure out how many hours? Or do we want to figure... We want to figure out how many bicycles, right? So the total number of bicycles should go here. And how am I going to figure out the total number of bicycles? Using the remaining pieces of information. I heard multiplication, but what am I going to be multiplying? Kyler. So 15 times the number of hours in production. So all I need to do is replace total number of bicycles with its variable. 15 stays 15, and then I have to replace a number of hours in production with its variable, x. So thinking back to what we wrote at the top, what's another name for the 15? What did we talk about at the top? At the top. Talked about constant of proportion. Throughout this entire time when we're producing, we are always making 15 bikes every hour. Every hour, 15 bikes. That doesn't change. That's what's constant. So the 15 is the constant of proportionality. And I really do need you guys to focus in longer than 2 minutes because I've got 3 or 4 girls playing with the ends of their hair. Okay? And looks like Sydney's doing something different than what we're doing. So I need you guys to focus on this. because this is what your test is going to be like when we are taking tests. So here's what I'm going to give you for homework. I'm going to stop right here.